you ready? Yeah, sure. Can we start? I guess. Well, thanks for showing up. It's actually a lot more people than I expected. My name is Frederik Steinmetz. That was pretty... That keeps changing. Okay, I'll try to talk directly into it. Okay, my name is Frederik Steinmetz. I work with Gottfried for blendediplom.com. And this talk is called Cycles Light and Magic. And the only reason why I called it magic is that in real life, of course, you can't distinguish, well, light is light. So you can't distinguish between a camera ray, shadow ray, and all the other rays. In photography, you just look through your camera and you take a picture. In cycles, it's different, and that's what I meant by magic. What you do is, every time a ray gets cast into the scene, it is a type. And every time it interacts with a surface, it actually changes its type. And you can see the camera ray is actually ray number 0. So the ray does not get cast from the light source as it is in real life. It gets cast from the camera, and thereby you can distinguish between different rays originating from the camera. And the first ray is always a camera ray until it bounces. So it hits an object over here. This is supposed to be a glass object, and that means at this point it has a chance to be either to become a transmission ray, which means it goes into the glass sphere, or it gets reflected directly, which means it goes away from the glass sphere. In this case, it would become a glossy ray, which is, you can see on this side, that would be a glossy ray. And of course, if it enters the glass sphere, it becomes a transmission ray. And after it hits the ground, which is supposed to be diffuse, it becomes a diffuse ray, and so on. And it disregards what it was before. So it's always only one type, except for the reflection ray, which would be any bounce of a diffuse or reflective surface. Any ray that is not a transmission ray is actually a reflection ray as well. So let's have a look at the outputs of this node. You can see the is in front of all of these, and that means it's either true or false. There's no half glossy ray, which means this returns either 1 or 0 depending on the type of ray, depending what object or what surface the ray touched last. Then we have 3 more options that don't have an is in front of them, which means that they can have values other than 1 or 0. The ray length is whenever a ray passes a transparent surface or refractive surface, including glass, its length will be measured from the point when it touched the object. That would be, for example, here, the length after hitting this point, the length of the transmission ray, that would be the ray length. So these are either 1 or 0, and this one is a distance, so it's measuring a distance. It can have decimals, whereas the ray depth and the transparent depth, they can only be integers, meaning whole numbers. That is, every time a ray bounces, and that includes the transmission ray, is also considered a bounce. So every time a ray bounces, this number gets increased, and the transparent shaders in cycles, they're not physically correct, so they are their own type of shader, and that's why they're captured with the transparent depth, as opposed to the ray depth. There's a slight distinguishing between the two. Okay, and I'm going to show you a couple of examples that I've prepared, and we're going to kind of ignore these because, well, the time is pretty limited, and I'm going to focus on the camera ray, shadow ray, diffuse ray, glossy ray, and the transparent depth. And the camera ray, I've already said that, it's before any bounce. As soon as a ray touches the surface, it is not a camera ray anymore. A shadow ray is a special sort of ray. It's kind of part of the magic because it's really hard to grasp what it is, I think. But we have I think a good explanation in the next slide. And of course, if a ray bounces off a diffuse surface, it becomes a diffuse ray. And the same thing with the glossy surface. And I've already mentioned, every time a ray passes a transparent surface, it gets counted, and this gets raised 1. Okay, one last look at one of the images. This is actually from the Cycles Encyclopedia that me and my colleague wrote, and there's a lot more explanation also, of course, on the topics I skipped today, those here. And you can see after the transmission, the ray bounces here and it bounces off the diffuse. And if we have only 3 bounces max, you can tell Cycles how many bounces it can handle maximum. You'll see that the ray bounces against this wall last, and it's terminated. So it never reached the light source. So if we wouldn't have the shadow rays, this area behind the sphere would be dark. Of course, there is a chance that one of these rays bounces towards the light source, but it's very minute. So chances are that this entire area would be very dark unless Cycles creates a shadow ray at each bounce. So every time a ray bounces, a shadow ray will be created and it searches for a light source. You can select if it's supposed to search for all light source or if it just takes a random one. Meaning this, for example, this bounce here gets illuminated by the shadow ray, as well as any other ray that hits the light source anyways. So this is kind of a method that I think all path tracers use. Might be some exceptions that I don't know about, but most path tracers do that, and every time they bounce, they search for a light source in order to illuminate the pixel more than an actual regular bounce would. So let's head over into Blender. And let me show you a few examples. What I have here is 2 cubes, and they're both emitting light. Actually, if I click on it, you can see it's an emission material. And the right one has an emission material as well, but I can now connect the strength of the emission, for example, to the camera ray. That means it's still shadeless. It's got exactly what color we specify here. It doesn't take into account any of the geometry. It will basically only show the outline. And also, as opposed to this light source, it will not illuminate anything else. It will only be emitting for the camera. Therefore, it will also not accept shadows, or receive shadows, I should say. This is a different example. These are 2 spheres, and right now they don't really differ in their settings. They both have a strength of 0.2. I just used the multiply node to show the similarities. But you can see that this here is multiplying the transparent depth by 0.2, and it's plugged into the strength. So right now there is no transparent depth, so this is 0 times any number is still 0, of course, and then it hits then this node is calculated with a strength of 0, and that's why why this one is actually shown black. And I've prepared something here. You can see this is a transparent shader, and also just to prove that this is magic, there's nothing in my sleeves. And you can see if I drag this across, you won't see the plane, it won't get rendered because it's 100% transparent, but it will illuminate this sphere, or I should rather say it will increase the strength of the sphere, because right now we're getting one transmission, one ray going through the transparent surface, and therefore we get the same strength as here, because right now it's 1 times 0.2, which is the same as the 1 times 0.2. And what is even more exciting, at least I think, is if I duplicate this, you can see now I have 2 of the transparent planes, and that means I get twice the lightness. So as opposed to these as opposed to these either or, this one actually counts. The other one had a camera ray, which means it's only for the camera is 1, for the rest it's 0, so it didn't emit light. In this case, it counts how often the light is emitted. And I can do this as often as I want, increasing the strength of this sphere each time I create a new transparent surface in front of it. And I have prepared a little addition to that material. If I now connect this, you can see the part of the sphere that gets hit by 3 bounces, by 3 transparent transmission rays. It gets green because from the count that the transparent depth gives me, I subtract 2. If this is smaller than 0, it will also return 0. I can hit the clamp, but it also does that automatically. Because if you use a factor, you can't get below 0 and you can't get above 1. That's just the nature of the factor. So it automatically clamps the values between 0 and 1. So if I were to duplicate this again, I would still get the green surface. And because now this is 4, subtract 2, which is still 2, which is greater than 1, and means it gets the lower material all the way. Okay. So that would be the transparent depth. And another example is, it's called architectural glass. You have, whoops, sorry, something happened. If I use a glass shader on this directly, I get, first of all, I get a strange behavior in the shadow, because I would expect that the diffuse material from the frame here would cast a different type of shadow than the glass does. And this would actually be true if I increase the samples and I have to enable refractive caustics. But disable that, the shadow will be treated the same way as a diffuse surface would be. And also if I turn on refractive caustics, I get a lot of noise. Right now this is just a plane, so the noise is at a minimum, but it will also count for all the other objects in your scene. So being able to avoid refractive or reflective caustics greatly decreases the time in which your rendering will clear up, so it will decrease a lot of noise. So it's actually preferable not to use the caustics. I'm going to turn them off now for the demonstration, and I'm going to have a look at what happens if you can see I'm bypassing this. This is normal glass right now. And what I like to do for the refractive, for the architectural glass, it doesn't need all the capabilities. It doesn't need to cause or to cast these refractive caustics. Can you actually see that in the preview if I turn them on? No. In theory, you can see that over here. There's caustics. The light that hits the bottle, it doesn't get reflected all the way. Some of it passes through. Some of it gets, I don't know the English word. Well, it gets concentrated, I guess, to form these brighter areas. And these brighter areas are very noisy until you have a high number of samples. Cycles isn't that suited to actually cope with them. So if you can avoid them, do it. And what I'm just simply going to do is I'm going to mix the glass shader with a transparent shader, and I say the shadow ray is the factor. The shadow ray in this case is any ray that would be blocked. And so that one, let's get back to this one more time. The shadow ray here gets blocked. So a shadow ray would actually be what happens after you pass the surface. So in this case, you can see now the shadow is nice and it's differing from the frame because the shadow rays hit a completely transparent material, which means they get invisible. And you can even change the colors of the shadow by using this method. Because the shadow gets created by the transparent material, because the is shadow ray is the factor to mix the two. So this is a nice additional effect that you can use using this method. I'm going to leave this at blue now, and let's have a look at another difference. You can see this is glass material. Everything except the shadow is a glass material, which means you get the reflection of the cone behind the glass, and you get the reflection of the cone in front of the glass, and they sort of mix. And this is realistic. If you look at a window from a different angle, you can see that this is actually happening. But let's say you don't want that. Let's say you don't want the cone behind the glass to be reflected from the backside, because I can easily imagine a situation or a scenario where that would be the case. We can exchange the glass shader by a glossy shader. Glossy shader would now reflect only the cone, but we can't see through the glass anymore. The shadow ray still can, so the shadow is still the same because the mix factor didn't change, but the glass is no longer transparent. We can't see through it. And a glass shader is actually a reflection shader mixed with a refraction shader by a Fresnel value. To explain Fresnel, that would take quite a while, so I'm just going to demonstrate it. I'm going to use a converter math shader, and I'm going to add the Fresnel to the shadow ray and use this as a factor. Now we can see through the glass. If we exchange those two, we can... I should have prepared this better. I think the Fresnel value is too great. Okay, it worked in the test. I'm going to fix this, and you can download the blend file. Pardon me? Right. No. It's it should be added. I'll fix this, and you can down. No. No refraction. No refraction. Just there we go. Now we have still blue. Okay, sorry about that. I'll fix that, and you can. It's the normals? Okay, flip the normals. Now it works. Okay, let's not get too crazy with this, because I have a few more examples, and also I think I'm running out of time. This is the wrong layer. Here we have a new example, because there is a huge difference between using the light path node on an emitting object or using the light path node on a normal object. The architectural glass was already an example where I didn't use an emitting object, and here I have another one. What I have is Suzanne in a normal scene, but I have a magic looking glass which is actually able to use it as an X-ray glass to look inside of Suzanne. So if I do that, you can see the inside of her head. No surprise, there isn't a brain. But we got some gears from the. It's an add-on in the trunk. I just used that to produce some gears. So let's have a look at that shader. It's a bit more complicated because I need the backside to be blue. So if I just mix that, you can see I can see through the entirety of Suzanne. You can see the background through her. But if I mix in the back facing with a regular diffuse shader, then this is what the background becomes. And you can see, just in case I use a glass shader for the magnifying glass, for the looking glass, I mix the two so I can, for rendering speed, I can either use transparent or I can use the glass. And that is determined by the fact that I'm adding the transmission rate to the transparent depth. And this is another thing I kind of forgot to mention. If you have an either or, you wanted to influence two different rays, you need to mix them with a logical or. So if you mix them by, if you use an or, like I do here, then it doesn't matter if it's a transmission ray or a transparent ray, they do the same thing. But sometimes I want an and, meaning if I only want something to react if it's a diffuse ray and a reflection ray or something like that, or and a transmission ray. That would make more sense. So a logical OR is actually an add, which sometimes confuses my students because add is kind of and add is in German is basically a very similar word. But if you imagine adding 1 and 1, it would still be 1 because we have the clamping. So 1 and 1 is 1, 1 and 0 is 1, and 1 and 0 and 1 is also 1. Only 0 and 0 will return 0. And if I multiply them, only if both are 1, we get the result of 1, because 1 times 0 or 0 times 1, 0 times 0 is all 0. So the logical AND would be add, the logical AND would be multiply, and the logical OR would be add. And I guess that's it with my samples. Oh, here we have one more. It's a bit more simple, so maybe I should have started with that instead of the Suzanne head. What I do is I use the same color and I invert it for this diffuse material, and I say as soon as you are reflecting in a mirror with a glossy ray, then show the inverted color, and as long as you're not reflecting, meaning the camera ray, diffuse ray, all the other rays, it'll show this color. So as soon as she gets seen in the mirror, the color is inverted. And with that, I think I'm out of time. And you go ahead and ask questions if you want to. No questions? Okay. Do I need to continue? I'm not sure. Well, I'm done with my examples.
Can you tell us where we can find more information on this? Because maybe I think some of us need.
Yes, the light path node is very complex. That's why I didn't go into detail about all the options. But there is a very complete source which explains it in detail in whole, and it's called the Cycles Encyclopedia, which is the book that we wrote, Gottfried and I, and you can get it on our homepage, blenderdiplom.com. I think, well, when I was researching the light path node, it took me quite a while to figure everything out. There was a chunk here, a chunk there, and it was really tedious to combine this all, and we did tons of tests because we got surprised by this node quite a lot. A lot of the times we would just, okay, why didn't that work as expected? Like you saw with the architectural reflection glass. That happened to us a lot, and we put all that knowledge, all the tests, we put into the Cycles Encyclopedia that you can get either at blenderdiplom.com or in the Blender eStore. And I think I don't think there's a source that's as complete, where you have all the details, information in one place. I don't think that exists.
Have you ever done any video course online?
Yes, on blenderdiplom.com there's a lot of video courses, but so far there's none about the light path node, if that's what you're asking. It's only in the book. Yes, please?
Apart from the architectural glass, have you seen any other real world examples?
I use it a lot, actually. For example, I don't think I have a scene where I don't use it at all. What you can do is, if you have an HDR lighting and you want to boost the glossy part of it, you can actually let's just do that, but that would be again freehand and might not work. For example, if I have a value of 1 and I boost the diffuse, well, right now we only have diffuse, so we won't see the difference. You can, for example, add to the strength diffuse, and that will, every diffuse surface will be twice as bright now. So if you know your reflections are too dark, or you want overexposed reflections but not influence the diffuse, you can just add glossy to your strength, and it will all, glossy to your strength, and it will only illuminate the glossy objects. You can actually see that here. The mirror is now more bright than the environment. And I think you can see it best like that. If I mute this, I get only the diffuse, and if I use this as a if I use a diffuse, for example, you can see the monkey gets brighter and the environment again. Okay, monkey gets brighter, glass gets darker. So you have very fine control over the different light sources. And you can also boost refraction, for example. If you use a transmission ray, you can increase the refraction caustics of objects of your scene, because they tend to be a little dark, so you can see them better. Yes?
How would you go about creating realistic caustics?
Realistic caustics in cycles right now take a long time to clear up, so I would wait for Metropolis to be implemented. But other than that, if you want to use, I would use mesh lights. And if you don't want to use mesh lights, you actually have to turn on multiple importance sampling, just in case you're wondering why your caustics don't show up if you're using spotlights or suns. They need to have multiple importance sample enabled. What else?
Can you adapt this to volumetric animation?
That would be the specialty of the gentleman to the right of you, two over. Yeah.
You can elaborate a bit about glossy shader and glass shader with very high index of refraction. Are they kind of similar?
What do you want to know? The glass shader, if you use a higher index of refraction, the factor of the Fresnel gets boosted as well. For example, if I only have a single colored background, so it's probably not going to see that much. I use a glass shader, and let me use a skylight as well, like so. And we need to go to perspective view. Okay, so if I boost we have a list of the IOR, the index of refraction of different materials in the book as well. If I increase Gottfried, do we have the glass shader as an example on the homepage? No, the glass shader. Well, let me just check. It might still be. That's D. Yes, the comparison sheet. Isn't that glass? There we go. Internet's slow here. Well, I think I might have them in the Dropbox as well. Oh, that's just the notes. Okay, we have tons of examples like that where, and let me see, maybe it's done loading. Oh yeah. If we go, as soon as this image is loaded, I can show you. Let me disconnect Dropbox, and it loads faster. Okay. Here we go. We have, for every shader, we have at least one sheet like this, testing it out. For some of the shaders that are more complex, like the Toon shader, where it's not just the shader settings and the lighting, we have 4. So here you can see This would be the difference between Beckmann and GGX. And over here you have sharp, and there you can see what happens if you increase the index of refraction. You can see that the higher the index of refraction, it's not only the stuff behind the object that gets more refracted, but you can also see the Fresnel effect of the surface gets increased. And in the end, if we have an IOR of 3, it's basically a glossy material. So for
Exactly glossy material, or there is some subtle
there should be some subtle difference, but the highest index of refraction in nature should be diamond, which has an IOR of about 2.2. So 3 is already beyond nature. But that's funny in Blender because a lot of the times they won't limit factors to realistic stuff because it works still with the mathematics behind cycles, so you can just go nuts, which sometimes produces very funny results. Yes.
Say if I have material which is kind of complex, and then I use the light paths so that if I see the reflection of that very material, it gets simplified.
Yeah.
So does that actually improve current time or make it worse because there's more noise?
What I would definitely recommend for that kind of test is these options. Because if you say it doesn't get shown in the glossy, it will not get shown in the lighting. I think you're referring to a paper from Disney where they were using bump maps in the reflections, whereas they were using real geometry in the objects. So what I could do right now is I could duplicate this object, then turn back on the glossy and disable the subsurf and I should also turn off camera. So this way we have. Oh right, it's let's not use glass for that. Let's use diffuse because it's confusing. Diffuse. There it is. And of course the other object should get diffuse as well. Now that. Why is that black? Why is that shown by camera? Oh, yeah. Right. And let's just turn off everything. There we go. Okay, there seems to be some. Okay. Yeah, that's. Alright, I forgot we're looking for diffuse. Yes. That would be the technique. You would use the high poly object for the camera, uncheck its glossy visibility, and in the reflections you would use a low poly object with a bump map to simulate the. Because I think actually the render times might get worse with the method you just described, but I haven't tested that. That's it? Okay, then thanks for listening.
Blend 1 ist kopiert worden in das Netzwerk. Dann habe ich die heute Morgen einigermaßen created. Aber das Glossy Ding habe ich nicht nochmal getestet. Eigentlich wollte ich es auch gar nicht zeigen, weil alle müsste es eigentlich und dann steht